Hello, everyone. Welcome to our webinar that we've put together for today, looking at digitising energy and water infrastructure assets, an enabler for operational intelligence and net zero emission transition, our online seminar that we've got. We're very fortunate today to have three industry presenters that have come from some industrial partners, some key sort of leaders in the digital utility transformation space. First up, we'll have Lynden Bow from Origin Energy doing his presentation, looking at digitising the energy distribution network at Origin Energy. Then after that, we're moving across to the water sector, where we have Milos Pelikan, who's looking at value chains and capability ecosystems, a framework for digital twin development. He's the digital asset technical lead within Melbourne Water. And then lastly, for our industry presenters, we have Mark Posdena, who's looking at the foundations for a successful digital future. And Mark is the general manager within Powerlink Queensland. At the end, we have our two researcher presentations from myself, looking at sort of R&D and training for digital utility transformation, and Mohsen from University of Melbourne will be covering more the industrial training hub that we're proposing around digitising engineering assets in Australia. So I'd like to hand over to our first speaker today, who is Lynden Bow.
Afternoon, everybody. Nice of you to join us for this session today. My name's Lynden Bow. I work for Origin. I work in the generation and development group within Origin. So today's presentation, I'm actually just going to focus on our electricity assets. Origin, we're a vertically integrated provider of energy, so we have various areas within our business, right from retail right through to our integrated gas business, but I'm going to focus on our generation assets. So just to provide a bit of context, we have a portfolio of assets sort of down the eastern seaboard, various different types of technology involved with our power stations, ranging from gas. We have Australia's largest coal-fired power station, Eraring, which has been in the news lately with an announcement of a retirement. We also have a hydro power station, and we also source a lot of our power from some power purchase agreements from some renewables. But we have announced a strategy most recently of investing in our own renewable asset infrastructure. So we're looking quite heavily into batteries, solar, utility scale solar, and wind assets. So we've already announced a couple of acquisitions around solar farms that we are going to be built. So where do we start? So about 10 years ago, we probably started our digital journey. I'm just going to give you a bit of background to where we've come from to where we are now. We decided to build a centralised monitoring and support centre, and to do that, so that was to control our assets around the country from a central control room. Now, to do that required us to connect with our assets, make and acquire lots of data, and be able to send control signals to that data. So it was the very, I suppose, embryonic stages of our data warehouse, where we take operational data, our real-time data, time series type data, and we also get transactional data, and we blend that into our data warehouse. Transactional data comes from lots of different business systems, ERP systems, risk systems, project management systems, action tracking. There's a whole range of things that we do with where we connect with that data. But when we do connect with that data, one really important aspect that we always consider is the balance between our cost, risk and performance to provide value for the business. So we just don't connect for the sake of connecting up and interfacing with different systems. This is to provide real business value and insight. Some of the various use cases that we then use that data for is external reporting, where we have high levels of integrity required around our data to make sure that the numbers that we are producing are valid and very represents the business how we've been performing. We use a lot of this data for incident investigation. So when we do have an incident, and this is more reactive type things, that we need to gather a whole bunch of data, whether it be what the asset was doing, or whether it was maintenance records, whatever it might be. We need to get hold of that data and get hold of that very quickly. We use the data for managing our safety, in particular process safety, which I'll just touch on very shortly. A lot of this is used for performance improvement, decision support, and predictive maintenance and planning, where we're trying to predict and analyse when faults might occur before they do. In very, very light print down there, and it's probably more for my note, is that we connect to a lot of different. We have a lot of different interfaces that connect to many different systems. We are processing quite a large volume of data every day. And our data warehouse is quite voluminous, as you see by we've got over 3 trillion operational records, well and truly over 650 million transactional records, and 20 million data points every day plus coming in. So a lot of data to manage and to wrangle and to be able to get that data into a structure that can be used by our system. Here's one of those use cases I was talking about around process safety. I'm not sure if people are aware of process safety, but it is quite a big thing within our industry. It's basically about how we manage risk, and that's the big risk, the things that can go bang and cause fire, explosion, harm people. So we have various systems in place to help to inform us to how we're performing against our process safety risks. And we do this by measuring various bits of data that can be associated to different barriers, plant, process, or people. A plant barrier might be, are we operating our assets within the limits that it's been designed to operate in? A process might be, have we got any overdue maintenance records? And people might be, do we have the right people trained for them to be able to perform that task that they're meant to be performing? So we measure this in near real time. We take data every day and we crunch the numbers. We produce a whole bunch of KPIs and we work out our risk profile. And so we have up-to-date information on how we're performing, or how our barriers are performing, whether they're preventive barriers or, if an accident does occur, mitigative barriers, how they are performing and whether they are in a position to perform when called upon. So we measure these every day, and we have governance around that, quite a strict governance process around that, and that's how we manage a lot of our process safety risks. So helps with that decision support. Another use case that we use our data for is around anomaly detection, and this is really about predicting when we may need to perform some maintenance on a piece of equipment or an asset. And we do this by taking some operational data sets. We then have a profile of what we think should be the right level of operation for that asset, and then we measure a residual value from where it's actually performing to what it should be. And using that residual value informs us whether we have an anomaly that's been detected, and that having that information allows us to properly plan and predict when assets may deteriorate. So we have about 490 different models developed for various types of assets or systems across our generation portfolio. and we're measuring these all the time, and we're getting alerted, and it certainly has helped us with preventing any sort of major events from before, as we've seen from process safety, but also helping us to plan our maintenance and when that should occur. Another use case for our data is what we call real-time optimization. Now, we collaborated with Synenco on an opportunity at our Eraring power station, which is that coal-fired power station, where we've produced some digital twins of some of the assets there. In this case, we've got some cooling water pumps that supply cooling water into the boilers at the Eraring power station. Those pumps, very large pumps, 6 megawatts each of a pump. We have 6 of those, very high risk assets. We need to get this right. But what we've been able to do here is we've actually got closed loop machine learning. So we take some inputs around what the market conditions are, what the weather's doing, and some of our own operational requirements, and we feed that into some algorithms and some machine learning algorithms to be able to make continuous little improvements to the assets to actually optimize their performance, and that's all automated. So that gets fed back to the control system. The control system makes those slight adjustments, whatever they may be, to optimize that scenario that we're looking at, and that information that gets fed back in, and it's a continuous loop around machine learning and using that information to keep making those small adjustments. You can see there we take about, we consume around 11,000 data points in real time, and of that we're capable of making 670 little changes on our assets in real time to get the best performance out of them. That information then also gets sent back out from our data warehouse back into our anomaly detection systems as well, which is another feed in for those. So I mentioned before about our new assets coming on board, renewable assets coming on board. So with that has its own challenges. We've always had very good connections to some well-defined power stations around Australia. But what we're finding is that these newer assets are coming with new methods of connecting. So from an interfacing point of view or integration of our data. So what we've embarked on, and this is our most recent thing that we're looking at, is industrial Internet of Things, or people know the Internet of Things, but with the industrial flavour over the top. We've come up with a model that we're working on where we have quite flexible services available to us depending on that type of asset, whether we need to dispatch and control it, monitor it, perform some asset management over it, do some visualizations for some decision support, or optimize that asset. So we're investigating at the moment these new ways of connecting to assets, these new assets that are coming on board, but it also provides us an opportunity to expand what we can do into other areas for different types of customers that we might have. The data that we're finding that comes out of these new assets is actually it's vast, and it's giving us capability to get new insights and be able to do new things with our own capabilities within the business. And one of those things is moving that real-time optimization down to the edge. So we have edge compute capability where decisions and new scenarios can be produced at the edge and fed straight back into that asset control system. So that's a little bit about where we've come from, some of the use cases we've had for the data that we do ingest over the time, and into what we're looking at next. So yeah, thank you for your time, and more than happy to answer questions at the end when it's question time, but I think I'm handing over to Milos now.
Thanks, Lynden. That was a really good discussion and actually quite a good segue into my presentation, which is about thinking about digital twins, which is sort of the flavour of the year, and just how you might think about those within your business. So I'm going to kick right into it. And what I'm going to do is try and tell you a bit of a story. And one thing about this presentation is there will be no technology mentioned. Look, I think it's fair to say the digital twin space is pretty damn confusing to a lot of people. This is just one definition. I don't mind this one, but you could drive a truck through that definition as to what that might mean for you. So one thing you can say about digital twins, though, is it is part of this broader digital transformation that's going on. And with this sort of objective, you know, sort of a kind of a blue sky objective of better, more enhanced data-driven decision-making. And some of those examples we just saw are examples of that. And so I want to sort of think about that a little bit first. That red dot there in the four-leaf clover diagram, for me, that represents data-driven decision-making. It's a combination of critical thinking, understanding the business, digital literacy technology, being able to tell a damn story, and of course, data literacy, understanding your data. So this is sort of a foundational piece of where digital twins are sitting. But in order to sort of think about digital utilities, and I'm going to focus in on water utilities, you really have to, before you're twinning everything, you really have to understand the world you live in. Now, a lot of people, when you say the words digital twin, think physical. They think you know, walking around in a room in virtual reality or some such thing like what you're seeing on the screen now. Now, there's a place for that in water utilities, but and I think this sort of in some ways reflects the last discussion. We are very interested in process, so we're almost like a manufacturing centre, Melbourne Water. We have two key products. Our products are giving water to the retail water authorities and taking away sewage and processing it. So we're very much more like a manufacturing space than a civil space. So we think process, and most of this discussion is going to be around how we think about digital twins in that space. So what would you be asking of a digital twin? So I've got some broad capabilities that sort of covers quite a broad church, a very high level set of capabilities. In terms of what you might use in a digital twin. And the first thing we might think about is, how does it work? Where and when is it? And what is it? And so you can see you can map those capabilities onto that that rule of three diagram as roughly in those kinds of spaces and combinations of those things. But there's some other things we ask about digital twins. We inherently expect them to be integrated, so integrated data and systems. So you've already heard that in the last talk. Certainly expect trust. So you can't make real-time decisions with machine learning if you don't trust what you've got. And of course, it's a new world. We expect collaborative systems and sharing. So these are kinds of some of the broad ideas around a framework that you might want to build in terms of a digital twin. So looking for some inspiration. So where would you go? Where would you start with this? Well, I went to nature, as you do, and there are two things about nature which are pretty interesting. There's this concept of trophic levels, and that's a very simple thing to understand. You can't have eagles without mice. You can't have mice without grass. And in terms of food webs, that tells you, well, what do you need? What things need to work together to give you a mountain lion? Okay, so how do you take those and use them? Well, taking those broad capabilities, you're not going to have simulation and prediction without a really good data infrastructure. And we've already heard that in the last talk. You're not going to have visualization without data. So you've got that sort of trophic levels in the capabilities you need to bring to bear. And how do we use this food web? Well, it's about taking those capabilities, mixing and matching them, and answering a question. We heard a classic question there: how do we keep the pumps running? So these are my two conceptual frameworks in terms of a framework for thinking about developing ideas for digital twins and actually implementing them. And I want to put this into practice now in an actual example. a sort of a case study, if you like. But before I do, I've got these 3 guidelines that I use quite a lot when I'm thinking about this space. Product need drives capability. So what's your product? What's your end? What's your service? What's the thing you're trying to achieve? Capability drives technology, never the reverse. So what capability do I need before I worry about technology? And the third one I like the most, that talks to the business person in me, minimum number of platforms for the maximum capability. These are my kind of stakes in the ground, if you like, and I won't be moved from them. So here's my little scenario. This is actually a real scenario. We've got some wastewater ponds at Melbourne Water. They're a resource for a recycling plant. Now, that recycling plant has to close down. It's impacted by water quality. And that water quality is influenced by weather conditions, so stirring up the ponds. Now, what we want to be able to do in this particular case is predict when, in advance, when that water quality is going to dip, so we can advise our customers in advance that, look, hey, look, next week you're not going to be getting that supply you said you wanted, or would you like to pre-order or something like that. So this is the concept. This is the thing we want to emulate within our digital twin. So there's the problem again, always starting with the question. And now I'm going to construct this concept using those capabilities I talked about, using this concept of a value chain. So to do this, I'm going to need some kind of interface. That's given. So I'm going to need an interface capability. I'm going to need to be able to develop that. So I'm going to need some capabilities in interface development. We talked about notifications. So we're going to notify in advance. So there's going to be some capacity, some capability involved in notifications. And of course, analytics that go with that. We're going to need a data warehouse. You heard just before, 11 million data points a day or whatever it was. So massive amount of information being generated, needing to be housed, to be managed, and so forth. In this particular case, we've got thresholds and compliance rules about the recycling water. So we're going to be able to have to manage those rules in some sort of way. We've got a predictive model. We want to see something into the future, so we're going to need to build in a capability into our twin that deals with predictive modelling and, of course, training. And we just saw that in the last one. Hence, it was such a good segue. Visualization. Everyone wants to visualize something. It could be on a map, it could be in a graph, it could be anything you like, dashboard, etc., etc. But clearly, visualization is a big deal. Certainly going to need some QA to ensure that what we're putting into our models and putting out to the public or our customers is fit for purpose. And in this particular case, feeds of data will probably have things like static information about contextual awareness, dynamic information about what's happened, so that's monitoring, and dynamic information about what could happen, which is, for example, in this case, the weather forecast. So here we have our value chain. This represents our digital twin. There's our capabilities, seeing the interactions. This is a diagram. Now, what I want to show you is you've got areas down here. So you've got a set of capabilities that are around data management and capture. Over on the top right-hand side, we have our simulation. Could be AI, could be simulation, could be some kind of modelling capability. And then over here, we have some kind of deployment or interfacing capability with our customers or people in our staff who use the particular model. So this represents a capability diagram. This is our value chain. This delivers the answer, so to speak. Now, what could we do with that? So what? We've got our diagram. What can we do with that? How does that help us when we're creating or managing a digital twin? Well, this is a diagram. What I'm going to do now is turn it into a map, okay? And the maps need coordinates. And the coordinates I'm going to use are need, which is effectively top to bottom in terms of the value chain. And I'm going to, in this particular case, I'm going to use a technology evolution scale for my x-axis. So you've got Genesis, custom. This is a very common kind of way of thinking about technology generation. It moves from, you know, brand new, cutting edge, bleeding edge, something from Silicon Valley, all the way to commodity, you know, basically on the web somewhere. I'm going to remap my digital twin, my concept to this. So I'm probably going to use something that's totally web-based and in the cloud. My notification system is probably something on-prem, interface development more likely to be in the cloud. Data warehouse maybe, in this particular case, I'm saying it's going to be an on-prem solution. The threshold management, that's probably a spreadsheet initially, so it's way over there in Genesis. Predictive models initially, probably sitting over here until we're happy with it. Data visualization out of the box, QA over here, and a plethora of places where you might think about data feeds. Now, why would I do this? The thing about maps is position matters. So in a diagram, it doesn't matter where those dots are, but in a map it does. And why do I say that? Let me show you why it matters. We can now use this map to think about investment. For example, what if I move my data warehouse from on-prem to in the cloud? What does that do to the value chain? I can start, because movement now has impact. I can see how does that affect my value chain, and if I do move it there, what do I need to do to ensure I keep those connections and still maintain that value chain, still maintain the digital twin space. It also does something like this. You can start to look at what sort of skill sets you need in your team to deliver this particular digital twin. So on the left, we've got looks like data science skills to me. On the far right, we've got some app development and IT infrastructure skills required. And down the bottom, last but not least, information management and domain expertise. So this is my team that's going to deliver. These are the skill sets I need. One or more people need to have these skills to help me or my team deliver this particular digital twin. And I call this a situation awareness map. So you can slice and dice this in lots of different, you can use this to ask lots of different questions about your twin, whether it exists, whether you're about to invest in creating it. You can start to conceptualize it in this particular way. So I'm going to take a little bit of a divergence here. I talked about those very broad capabilities, simulation, analysis and reporting, etc. They are extremely broad and high level ideas. Now, when you actually get to do this, you're going to be getting into some detail, and you shouldn't fear that because there are a lot of resources available. This has just come out recently, a thing called from the Digital Twin Consortium. It's called the Digital Twin Periodic Table, and underneath those colours there, the blue, the integration, etc., there's a whole raft of capabilities that have been defined, and they map to the concept in the trophic pyramid there. So you don't have to go and do it all from scratch. It's all there for you. I've used some very high level things to explain the concept, but you can certainly get down into the detail if you need to. So check that out. I think that's a fantastic resource. Only recently released it. It's something that's really worth having a good look at. So go shopping for capability. It's all there for you. You remember I mentioned, I'm going to finish off soon. You remember I mentioned this minimum number of platforms for maximum capability. What's that about? Well, that particular twin, that example that I showed you, and certainly the one that Lyndall showed you, they're quite specific, and that's good. They focus in on a business problem. So what's likely to happen in these sort of process twins is we're likely to have an ecosystem of them. We're likely to have more than one. Very, very likely. In fact, you could almost, I'd put money on the fact that we would. So the maximum capability for the minimum platforms is saying, how can I develop or deploy a set of capabilities that I can share amongst these twins? That's what I'm looking for. I'm looking for technologies and platforms that give me that maximum benefit, the maximum ability to use the capabilities within that platform to service as many of the twins I need to deploy to do my business. So in this particular example, you know, common data services, common trust platforms, common data management, etc. So you can see that's what you're looking for here. So it's not about technology. This is about saying I want that capability, and I want a platform or a small set of platforms that deliver the maximum amount of capability possible. So that's a really important part of the framework. And just to finish off, before I hand over to Mark, reminding ourselves of the principles: product drives capability. So need drives capability. Capability drives the technology, never, ever in reverse. And that minimum number of platforms deliver maximum capability, and of course, delivering value into the business. So thank you very much. Hand over to Mark now.
Hi, everyone. Hopefully you can hear me at this point. So my name is Mark Posdina. I'm the General Manager of Business IT for Powerlink Queensland. And I'm going to tell you a little bit about the journey we are on at the moment. Quite an extensive digital transformation journey. Still lots to do, but I want to talk about the foundations of what we are setting to build to that very important future for us as a company. And certainly the two presentations have had very interesting stuff, and a couple of parallels with some of the stuff I'm talking about. But I will set a little bit of context first, just explain who Powerlink is, because sometimes I do come across people like, what is Powerlink? So really simple. We're an electricity transmission system operator owned by the government of Queensland. We have a transmission network. Hopefully on your screen you can see a nice map of Queensland, and you can see our transmission network extending from the north of Cairns down to the New South Wales border. A lot of connections there, and connects 147 substations. So it's a big thing, big beast. And we're in an industry right now going through an immense amount of change, and I feel there's in a good way. As a company, we're adapting to meet that change. And with that change has come a lot of growth as a company, and a lot more work as well. So what is it that we need to adapt to as a company, or are doing to adapt to meet this change? And I'll start with what it is that we need. And a lot of my presentation here is around capability. And essentially, this is the ecosystem of Powerlink, the screen you have there in front of you. And all of these people are part of what makes up Powerlink. We have everyone from our people all the way through to our landholders and the community where our network resides. And what is important here is, and I'm not going to read it all out, is across all of those people, is they all want the same thing. They want access to the right information, tools, and resources. It's pretty simple. And that's the core of the capability that we want to deliver. And we're an organisation that has, we're going through a lot of change, and we've spent the last couple of years on starting our digital journey. And we've come from an environment where we've had a lot of legacy tech. And with that legacy tech comes a number of challenges, and I'm only going to talk about two big ones. And you've certainly heard it in that wonderful talk there about digital twin, is some of the importance of integration and accuracy of data. And when you have an environment such as ours, particularly on the IT side, and anyone who's ever worked in an IT organisation that's been around for a number of years, they have the same challenge. And it's this lovely diagram that I have there, that if there's anyone watching that has seen me present before, you're probably sick of this picture already. It is the spaghetti monster of integration. It is decades of unplanned joining things together with no real end picture in sight. And at that point in time, if it got people working and able to do their jobs, wonderful, but it is a big limitation when you want to move forward in the world of the digital of now. And the other piece there is, when you do have a spaghetti monster like that, is you have conflicting sources of truth. And we talked about the importance of data earlier on in decision making, real-time decision making, and so forth. You can't do that if you've got multiple systems that tell you 10 different things. And that is one of the big challenges when you are going through a journey like the one we're going through, because you're unpicking a bit of this, but you also want to avoid it. And so our approach is, with these challenges and everything that we need to do, how do we do this when our industry is going through a lot of change? And that change is like pretty simple. It's a big increase in renewable connections, the transmission network. Personally, I think that's a great thing, and is a big step forward for not just Queensland but Australia. But with that change comes growth and need of new skills, capabilities, and so forth. But if we're doing all this new work and we're going through this growth, driving a tank through and changing all this stuff at once, it will be disruptive, and it will stop us being able to do what we need to do. So we know that there is a lot, and I'm just struggling with a mouse, but we do have a lofty digital ambition. And these are 6 very key areas where we have a huge number of initiatives that are looking at every part of our business to move us forward, to give those capabilities. And all those people you saw in the ecosystem before, those very simple needs of right tools, right information, right time when they need it. So just touching off on what it is that we're doing, we've got starting there on the left, and I'm not going to read the words. I'm just going to, I guess I will talk about technology a little bit. So next generation network ops, like one of the things that we're delivering there is a new electricity management system. Electricity management systems you don't replace every couple of years. You replace 20 years apart or more. It's a once in a generation change that you look at that type of stuff, and it gives you a capability that can plan for this next future that is coming. We've got field people, like a lot of organisations like us do, and you saw that map of that quite vast area of Queensland that we need people out there. At the moment, a lot of the information tools they have are still paper, which boggles my mind this day and age. So digitising some really basic stuff for them, but moving through to where we can actually take advantage of new capabilities in an EMS and really deliver value to them with new data. But foundationally, we start small. ERP, so for those that don't know what an ERP is, simply put, it's a lot of where all the corporate stuff sits. It's your people information, it's your money, it's your finance, it's your payroll, but then it also includes your asset information, includes your logistics, and it's quite endless, it's huge. If your EMS is controlling your world of network operations, your ERP is controlling your world of your business operations, both vital components of the environment of one like Powerlink. And next to that, there's a program they call strategic data. So can't do all these things without actually looking at that bigger picture of what is your data strategy as a whole. And foundationally, it's pretty straightforward what we want to do there. Consolidate what we have into a more usable and available set of data sets and capabilities and tools for data-driven decision making. Digital engineering. So just heard from my friend there on digital twin and all the amazing stuff that can do. That is ultimately one of the core outputs of what we're going to get with something for digital engineering. It's the newest of our programs, so we're actually quite early on in the beginning of it, but there's other things there such as new spatial systems as well. Now, there's a great question in the Q&A about security. I won't answer it, but it does call out, you're doing all this stuff, what about security? And that's what we've called out in our digital transformation program is, as we are doing all this, we need to make sure that we keep security in mind. It is, as we increase the digital footprint of our company and what we do in our reliance, it increases the cyber risk. So we have got a major program that is also transformational in the way we work and really drums into that fact that security is everyone's responsibility. So that's all the stuff we're doing, but we're not jumping to the end game and trying to boil the ocean. What we're trying to do is deliver those foundational pieces for our digital future and building from them. And an example of that is not just making sure all those programs align and we're not crowding the runway, delivering stuff and disrupting our company, but it's actually understanding in that end picture how these systems will operate and talk to each other or support each other. The NGNO, so the next generation EMS is an example. Where's it going to get its base asset information from? It's from the ERP. So you've got that real-time information, and you've got that static information or that information at that base asset level. Very important to have those things talk to each other. Those are just conceptual examples that are there, but that's what we have, how we've approached our program of work, so we don't wind up with just a newer, shinier, more expensive spaghetti monster. And that's been a key message as part of our foundational piece. So not to disrupt, deliver value in bursts that are achievable, but don't wreck the organisation where they're already going through this change. That doesn't mean you can't get wins. And this is probably another important message is that, yeah, that sounds like we'll be waiting forever for that high value stuff. No, it means that what we've done is we've strategically changed the approach of what we're doing so that we can get wins now as we need them and build those capabilities as the company develops alongside of it. So there's a number of wins there, but there's a couple of real key ones there that we're already getting gains from. We've got a data lake, which for anyone out there, I won't even attempt to explain all the intricacies of it, but it does give us a better capability to understand our own data earlier. New spatial platforms, improved reporting, like that is actually really something, it sounds like, well, that sounds boring. If we can make decisions faster, get the information clearer, and it doesn't require some poor person to work through a weekend. We're doing things better. And we even just had a big recent win with a major ERP upgrade a couple of weeks ago, which was, well, it's SAP. I'm not supposed to say brands, but I'm from my own company, but SAP is important to what our future is from our operations side. And the last thing I'll touch on is kind of the flip side of digital twin. One of the benefits of digital twin is using that augmented reality to actually be able to look at everything from safety, construction, and all those wonderful things you can get out of one of those dynamics. But that doesn't mean you can't use those tools to make them part of the daily work practices of people we've got now. And so we've been using a technology such as HoloLens to actually get our people used to the concept of using that technology, even just in a way of remote work, using supporting remote work. So having people in other areas who can support people out in the field with that live view. And we're well on our way. We're getting those wins. But my absolute last message is that the most important asset we have in our digital transformation is our people. We've been talking about data today and business process and so forth. The people that know our processes best and know our data best are it's our own people within our company. And it's not just always about the technology, as I've said there on the screen. They know all those processes and systems in and out. And more importantly, as we're making all these big changes that will affect our future, they have no issue with letting us know if we're steering in the wrong or right direction. They don't care about a program report that says that everything's green. If it's going to affect how they do their jobs or how they do their jobs in the future, they speak up and they share the right information. And the people at Powerlink are wonderful, and they're investors in our future as much as anyone. So that's just a real deep dive on everything we're doing. Any questions, throw them into the chat. And I guess I'll hand back to Rodney.
Great. So I just want to talk for a few minutes just on the role of R&D and training to accelerate the energy water sector digital transformation journey. I've been involved over a number of years through a range of different programs supporting research with various water and energy businesses. And we've been using university-supported ARC linkage, direct R&D funds, Advanced Queensland, really with the different water energy businesses doing pilots and trials, playing with data sets, coming up with those models that may be connected in to analyse data to provide some predictive analysis about water demand or energy demand and supply and or asset decision making. So a lot of that sort of leverage funding coming from industry partners into those research programs have, I guess, led to some learnings that have been taken up by those partners to help them on their way of that digital journey. Because a lot of the time from the work that I've actually seen is that we need some little bits of evidence to help with that business case to then get the funding internally to do that particular digital transformation that needs to be done. It doesn't happen overnight. We've heard some great little snippets of cases and different stories of good practice and how they've transformed their business from the partners today, but they'll also tell you of some of the challenges they've had getting there and maybe some of the failed projects they've had, because this particular digital transformation journey is a windy road. The spaghetti picture I like from Mark is great. There's still lots of things to resolve, and cybersecurity, looking at many of the business re-engineering changes that need to the standardization interoperability. It's got a lot better. It was horrendous 5 years ago, but we're starting to get better interoperability between the different, numerous enterprise management systems that are being used by organizations to be able to talk to each other through data lakes and things like that. And lots of other different areas, even in the regulatory market transformation space, so more the management and policy regulation, legal aspects of this digital change yet to be resolved, and still lots of things to be worked on. So I see that R&D plays a role, and I've been part of that mainly through industry collaborative projects with various industry partners, but really about conducting those pilots and trials to see where the value comes from digital transformation, creating those business cases, finding out benefits from if we re-engineer the business to do something differently, what would be the savings. It's not immediately evident what they are, and sometimes some of those business cases are oversold, particularly by companies that are selling products, software products and services, so they're not necessarily realised in practice. And I think that R&D, from what I've seen, provides that low risk, low cost sandpit to trial new technologies, approaches, and explore what can be done with data. You know, we often have big asset owners, usually government, quasi-government, or private companies. They've got all this big data now, and they're really exploring applications and business cases on how to do that better. And a lot of that involves the development of new algorithms. In the broader sense, it could be feature recognition of satellite data, text mining, visualization, and often development of some software. And, you know, a lot of that is done by researchers. It's done in a sort of a beta form. Might not be the best final product, as Milos talked about, but it needs to be integrated into the more sort of integrated, you know, seamless systems that are already in the organizations. One thing talking to water and energy businesses is that a big focus now is around the people. There's a real change in the types of skills that your organization has in terms of asset management, in terms of operations, and there's a bigger focus around data science and analytics. So there's opportunities with industry masters and PhDs in terms of upskilling and having embedded PhDs, embedded master's students to play with this data, look at opportunities for better decision making for asset or operations management. There's also this sort of digital maturity, competency assessments that always got to reflect back on the people, the technology, the processes and systems. And often we've worked with, you know, organisations like Queensland Government, SEQ Water recently, just doing that sort of independent assessments as well as the visioning facilitation around some of those changes that need to occur. And obviously there's the targeted training and the packages and key learnings that you know we need to translate back as a higher education sector from the different projects we're working on, and translating that back into webinars like this or targeted training packages that can be picked up by people to get that particular change. So I just want to really cover off very quickly on that from an R&D perspective. And now I'll hand over to Mohsen Kalantani from Melbourne University and just talk about the training centre about digital engineering assets that we're proposing here.
My name is Mohsen Kalantari. I'm from the University of Melbourne School of Engineering, and I'm going to join the University of New South Wales from next month. We are working with colleagues from University of South Australia, here in Melbourne University, University of New South Wales, and Rodney's team, Griffith's University, on a bid for an industrial transformation training centre around digital engineering, building capabilities in Australia for digital engineering. So essentially, this is one of the major, if you like, grant streams of the federal government, which facilitates the partnership between the universities and industries to build capabilities for major challenges in Australia. And how it works basically by embedding higher degree researchers like master or PhD students or postdoc in industries such as the industries the colleagues today represented, to really address any challenges that they have or build on capabilities and create new capabilities that they want to invest in. Now, we are working or building our case on a number of drivers that currently industry faces, some of them already mentioned by colleagues, like issue of health and safety in terms of the asset management, broader, bigger challenges like climate change and their impact on the operations of the assets, and also the reality that investments in infrastructure are becoming much more bigger, international, complex, and riskier, and how digital engineering, the capabilities that we can build in Australia, can help addressing these issues. Now, who we are targeting in this center, in addition to the utility sector that we heard in terms of their ambition for future, we're also looking at oil and gas industry, mining, civil infrastructure, and also building sector to where they are asset intensive and they want to upgrade their capabilities, human capability, particularly in these areas, and bringing all the service providers like cybersecurity companies, IT, geospatial surveying companies, and software engineering, and building that ecosystem as a training center to be able to build a capacity for Australia for future to be able to better manage our valuable assets. So this is a training center, as I said. So the ultimate goal is to basically provide human capacity at the higher level, like PhD or postdoc and master, for the industry. And there are some currently gaps in the industry, like we don't have enough digital and cybersecurity people with these skills. We have low level of female participation and fewer students taking these type of studies, and also increased competition for talent at the global stage. So how we can ensure that we can retain these skill sets in Australia. So these are some of the challenges that we are hoping with this center we can address. So this is my last slide. There are 3 pillars that we are establishing in this center, or proposing. One is industry-led research, as I said. So research that proposed by industry, hiring postdoc, PhD, or masters that go and work in the industry, embed there and understand the issues and address the issues of the industry, with the supervision, obviously, from the academics. Second pillar is industry engagement and upskilling, where we have interns going to the industry, upskilling professors of practice, colleagues that presented today, for example, coming to university. We can make use of their knowledge, and also they can also get updated with the technologies, and also a series of credited, non-credited courses that we can create. And finally, translation and commercialization pillar, where we will make sure all the PhD and postdoc and master projects are exposed to this translation of research, if you like, pipeline, so they understand that, as Milos mentioned, so we want to build capabilities that address the problems, the real problems. So that's another part of this research center that we are trying to establish. So if you are interested to get to know more about the center, you can either contact me or Rodney. My email is here, and you can always find me on LinkedIn as well. Thank you.
Hi, so we can go over to do some Q&A now. We only have 5 minutes formally left in the session, so we went a little bit over time, as always. But I'd like to open up, Dalia, so all the presenters can speak, and just propose some Q&A. We only really have one question there from Roger to start with, but I think it's a good one. It's the one that comes up as we become a more decentralized network. You know, the Internet of Things network has sensors and things can be hacked everywhere. Yeah, just open up to the panel. Anyone can answer. I think all can answer this from their perspective of their organization about how they're handling the cybersecurity threats and challenges.
Happy to go first.
Yeah, go for it, Mark.
If we're all live, not sure if we are.
Yes.
Well, if everyone can hear me, look, this is a great question. I did, and it's something that there is no single answer for, other than organisations just need to continue to prioritise cybersecurity in general. But there is no way to protect against everything. It's impossible. The organisations such as ours, they need to invest in not just the protection, but the ability to respond and recover. And that is as important as, you know, just about anything you do. The other is just the general awareness. Most of these big attacks don't happen through some, you know, nefarious squad of people in a, you know, in a bunker somewhere trying to breach through a firewall. It's through some of the most simple means, such as an email. And so the awareness across an organisation, understanding the risks around just opening an email from someone you don't know, that is sometimes as important as the technology put in place. So organisations like this, to prevent a colonial event, invest, focus on the all major aspects, not just protection. And the colonial incident, as particularly, it actually, the security side didn't actually get affected by the security breach, the operations of the pipeline. That was actually a board decision based on risk because their IT side had been breached. And it was the right decision to make to stop there being any longer term. Although there are a number of people across that country would probably disagree.
Yeah, look, just to add to that, there's an additional kind of security threat, not cyber specifically, but the digitisation of the process means we're increasing our sensor load out in the world, and we have a big and dispersed asset base, Melbourne Water. We have lots of incursions by people into our land for nefarious and non-nefarious reasons. And so those sensors, the more we digitise and become reliant on automation and what have you, those sensors become exceptionally critical, and the security around those, and there are thousands of them out there. That's an aspect of cybersecurity in a sense, that the network itself it's not just about internet incursions. There's everyday things. We have people every day incurred, funny people who want to go for a swim in one of the dams at 2 a.m. in the morning and all sorts of nonsense. So, you know, that's part of it as well, because in the past it was physical and you could go and crank a thing and make it all work again. Now we're literally relying on, you know, real-time sensors, and if they go down for whatever reason, whether it's from an email or someone simply tripping over and stepping on it, you know, all those have impacts on delivery.
I wanted to propose a question to, I think probably Lynden, just regarding interoperability. I always, whenever I talk to a water or energy company, they give me a map of all their different enterprise management systems, and one of the challenges they always talk about is getting data out of the front end or the back end of this particular package or software, and then putting it in their data lake or to integrate it with something else, because we want to integrate more now, but they're not always finding that easy because of proprietary or non-proprietary or interoperability. So Lynden, I just want to know your experiences, some of the stories from within Origin about some of the challenges there.
There are always challenges. Interoperability. There are some better standards coming out around interoperability, especially around sort of at that industry sensor edge device type thing. But yeah, look, there's always challenges. We have worked pretty hard over the course of developing up that massive data warehouse to bring sort of different types of systems in, and normalization of that data and the standardization of that data, and then being able to link that data together becomes really critical. I think there's some pretty good tech around to be able to allow us to like get the data, import it, but it's always comes down to, well, then how do you actually link these bits of data together that may come from completely different systems and could be down to as simple as, well, we refer to this site as A, but the same site over here is referred to it as B in this system. So, you know, how do we actually make that work together when we're trying to blend these two bits of data together? So always challenges around there, but we have got various systems that we have improved up over the years to help us with that.
Yeah, okay. So that's just even getting those typical database principles, you know, uniclass or, you know, and standardization of descriptions and things like that. Still, yeah, very important, right?
You go to low-level data types; they're all different in different databases, and yeah, it's always got challenges.
It's probably, you know, the advent of platform connecting systems is easier than it ever was. So you can phone up a friend on the other side of the world, no problem, if you think of it that way. But connecting a system, it's almost trivial in terms of APIs, and, you know, I won't say completely trivial, but you can connect them up pretty straightforwardly. But can you say anything meaningful? And therein lies the data rub. Melbourne Water, same problem. And it talks a little bit to Mark's spaghetti diagram. I like that too. I thought it was fantastic. I'll have bolognese, thanks. You know, these things have been built in isolation. People haven't really thought through, you know, I call an apple, you call it a pear or a persimmon. We're all talking about, you know, oranges, and it's that is the integration problem. And in fact, the advent of platform, I think, has exposed that more than ever before. It used to be, oh, we can't connect the systems. Now we could do that really easily. We're kind of focusing on, oh, the data's not so crash hot. and that is a big challenge. How do you transform all that to a common data model without shutting the business down for 2 years?
Yeah. And Mark, I have a question. You talked about people at the end, and I think, you know, they always say technology moves, but people and processes are slower, particularly, you know, in large quasi-government or government-owned corporations and things like that. What's the strategy around people in terms of, you know, getting the data science skills, or is it sending them off for some courses, or is it like looking for when you do new recruits, is to look for, like, change the job descriptions? So it used to be asset manager, you know about this, that, and the other. Is it actually changing those? So what I'd like to know, yeah, in practice, what's happening in an organisation like yours?
Great question, and something that, again, I don't have a complete answer for it. I'll probably use security as one where we're probably a bit more mature, because given, as the question in the chat, that risk and security is one of our key priorities with that risk. And so we do a mix: build, buy, develop, and a number of our roles across our group, even, you know, your more apps person or even data person, security is now being built into their role. And that is one of the ways we've been able to complement the new security specific people as we bring them in, or the security services that we buy, or the technology innovation that we put in. And it's the only way we can do it. And it's the same with data. It's just, we're just a bit further ahead with security than we are, for obvious reasons around risk. So it's the same thing. Develop those data skills, buy them in where it makes sense. We like to buy in skills for stuff we only do once. Develop our people, and certainly those are our priorities in that data and security space. So lovely to hear all the different opportunities out there for those development, but we have to be creative because they're in such high demand.
At Origin, we love graduates.
So
we love graduates coming in. We've had quite successful graduate programs. They bring a fantastic way of thinking to the organisation, and yeah, we have graduates on a yearly. We take summer interns as well. Like, we just love bringing that diversity into the organisation and that way of different ways of thinking and attacking problems. It's fantastic with really good skills.
Yeah, that's great. That, because it's the you might have someone who's not as street smart, but I always say you gotta you've got people who are street smart, but you've got also people that knowledge of some new ways of doing and thinking, and and blending those together to get the outcome you want is a good way to go. And in terms of graduates, our role in universities, I think, is to really also integrate more digital into the curriculum. As much as we can, and some academics are doing it better than others, but also I see these industry PhDs, industry masters are a great way to get very smart people onto some problems, and it works really well if the alignment is right, and it's a very big win in terms of what they produce for the company. As well as the industry generally, because they're doing something that's generally published and disseminated internationally. So I've seen some great outcomes with that, with some really good people. And one actually works at Origin Energy, Lynden, who's actually my PhD graduate, and she is one of the I think a manager within Origin Energy now. So with a PhD and environmental engineering degree. Making great contributions, and the skill set may not be exactly what was in the PhD, but it's the thinking and the problem solving at that next sort of level. I think is what you have as people who can adapt and really evolve to solve problems in a sort of rigorous way. So so that's one good experience with Origin before. I also have a quick question for Milos around I've sort of with digital twins and the hype cycle around and we're doing a webinar, and I've been on many webinars where there's lots of the hype. I think this is actually a bit of a ground truth webinar today, which is quite good. It's been a really good level. What's your sort of thinking around, the hype versus the incremental strategic change that is now happening in the water and energy sector, and where you think we've got a good point now, we're on a strategic journey, or we're still caught up in the hype?
I think we're still on the hype curve for sure. The digital twins are, and I deliberately in that framework stay away from technology, because I just don't think, it's all things to all people at all times, and so nothing to no one ever. And that's primarily because it's been pitched as technology, not a way of working and a way of thinking about capability for a business. So, I can't tell you the number of times I have software vendors come and tell me about their new digital twin. I'm sure my colleagues have the same experience. Seems like everyone's suddenly discovered they've got a digital twin solution. So I've really tried to get Melbourne Water to think about capabilities we need, and you can see from the other discussions, it's really about capability and not just technology capability. You look at that capability, those capability ecosystems, that also talks to people, as I tried to emphasize in that capability map, really trying to understand, as we create these more complex interactions, like a true ecosystem, it's unlikely that one person, we can go and cherry pick one person to solve any one problem anymore. It will probably become far more collaborative, and so we have to understand the mix of people capabilities that we need that reflect those problems. So where are we at? I'm actively and rigorously trying to pop the bubble on the hype and get us away from that into some sort of reality. And that's why I focus in on process, because in a water utility, that's where we spend all our money. So follow the money. We don't walk around buildings, and that's what our operators can do. They can walk out a door and walk around the building. So doing that digitally is not, apart from safety issues, is not a huge ROI thing for us. But being able to take 10% off inputs, or reduce our power input, or reduce our emissions, they're things that make sense in the long run, and they're things that will make digital twins useful. If we can't do those sort of things, then it will just fall off the fall off the cliff, and someone will come up with a new term to do this sort of stuff.
Yeah. Oh, that's great. Okay, well, I think we're sort of 10 minutes over time, so I might call the webinar to a close and just finish by thanking our three industry presenters that we had today, Milos, Lynden, and Mark. Thank you very much for your presentations today, and I think this was good because it was not a hype on digital twins and digital transformation. It was actually a very balanced discussion about the value, realizing the value from digital in a sensible way. I don't know if that's a title, but maybe we should have titled the webinar that way. But I'd just like to also thank Mosen for coming in and talking about the training hub that's being proposed. And in the background, we have Galia and Samindi that have been helping out with the webinar. So thank you very much, and I hope you have a good evening. Bye, everyone.